sample mean interval. So I kind of like that way we labeled with the proportions. So even though there's only one sample here, I'm going to do it anyways, and I'm going to say, so we're going to say mu equals true population mean of whatever, context. So remember, we look at a sample, like a small slice of the data, and we try to make some kind of inference or some kind of claim about the big picture of the population. So we would say we want to estimate mu at a blank percent confidence level. So the conditions are a little bit different, like two kind of the same kind of different. So you still need you need randomness. So stated or assume. You need independence, which is the n is less than 10% of the population. And then we're going to use what's called a t-distribution, which I know you don't know what that is yet, but we will get into that. And to use a t-distribution, we need one of three things to be true. We need one of, and we've talked about them. We talked about two of them before a lot, and the third one we don't talk about it. We didn't talk about it a ton. It's not super common, but it does come up. You need either a normal population a large sample size, which is 30 or more, or a dot plot that appears approximately normal. That's the annoying one. So typically they'll either give you there's a normal population or a large sample. But sometimes they'll say like the population is skewed right and you have a sample of like 20. And then you have to actually make a dot plot, like put dots for all the values and then just right next to it like appears approximately normal and then you keep going. And they don't do it very often because I think they know it's pretty annoying, but I've seen it that they do it. So we're going to talk about it. All right, so this is the same setup as the other one. So statistic plus or minus the critical value times the standard deviation of the statistic. So go ahead and get your formula sheet out too. You need more than over here. So we got our the normal confidence interval thing. Statistic plus or minus critical value times standard deviation of statistic. The standard, let's just start going through them. So statistic, if I have a sample mean, what's the notation for that? Like what letter or whatever do I use to represent sample mean? That's not on the formula sheet. You guys are making me sad. What's population? It's close to x. It's almost x. X is part of it. X bar. Maybe I didn't ask the question very well. What's population mean? How do I represent that? We already wrote it on the frickin' paper. Mu. Thanks, Evan. Mu is population mean. X bar is sample mean. What about proportions? What's the population proportion? P, what's the sample proportion? P hat. Alright, now I'm happy. Okay. The critical value is actually T star. So we're using, when you're dealing with means, we're going to use what's called a T distribution. And we will get into like what is a T distribution, why do we use it, I just don't want to do it yet. And then the standard deviation of the statistic. So we've done this before, and it's on your formula sheet. If you forget it, so single sample, we have one sample. We're dealing with a sample mean, which is our X bar. And the standard deviation of a sample mean, if you remember that from before, is the standard deviation divided by the square root of n. Remember working with that? So this is your formula in words. This is your formula in symbols. We're going to put the formula in numbers. This T star, what you're going to type in here is inverse T. So T is like a separate shape. It's very similar to normal. It's not the same as normal. But for Z star, Z represents normal, so you did inverse norm. For T star, we're going to do inverse T. And you're going to do 1 point, whatever, divided by 2, comma, the degrees of freedom. And the degrees of freedom in this case is n minus 1. Again, I totally understand you have no idea what that means. For now, just write it down. We'll get to it. I'll go through examples. I'll show you. What? You like that? Degrees of freedom. Gateway test is badass. I don't know what you're talking about. Then you plug in numbers. Then you get your blank, plus or minus blank. This is what I mean, like the general setup is all the same, right? Like this part is nothing new. All that's really changing is like one condition is different. The math box changes a little bit, but your overall process still follows through the same flow. So this is still your point estimate. This is still your margin of error. And our conclusion is the same. We're just going to use mu instead of p. So we are blank % confident that mu. So remember, this is like my shortcut. I need to put context in my conclusion, right? But I have assigned context to mu up here, so then I can just use mu from that point forward. So I'm just kind of saving writing a little bit. Is between blank and blank. Questions on mostly like what any of that says right now? I'm sure there's questions about what I'm talking about, but I'm going to do one in a second. Before I do one, is there anything I can address on the template here? So this is your third template, right? You have a one sample proportion, a two sample proportion, and now a one sample mean. And so then we have two sample means to do also, then that's when we'll stop and take a test. If we're still in school. Okay, so we're going to do number 1 on the sheet I gave you. National Fuel Saver Corporation. Can I take this away? Okay. So first thing is always label the test. But just think through why. Obviously it's a one sample mean because that's what we're doing like today. But just read through the question. Is there one set of data or two? There's one. Are we dealing with means or proportions? Deal with means, and then is it asking you to answer a yes/no question, or is it asking you to estimate something? It's asking you to make an estimate. So that's how we know. This one literally says make a confidence interval. That's a pretty good clue too that you should make a confidence interval. But so that I know that I'm dealing with a one sample mean interval. So take a second and see if you can label mu, maybe in your head, maybe on your paper, whichever. What are we trying to estimate here? Don't say it out loud yet. This question is written horribly. You didn't write it. Wait, why'd you say thanks? What? Oh, it was a sarcastic thing. Gotcha. So, it talks about the mean gas mileage increase, and then it says estimate the mean fuel savings. Well, that's garbage. We're going to estimate the mean gas mileage increase, which I suppose does lead to fuel savings, but that's not how it was phrased. So mu is going to be true population mean gas mileage increase. And then we want to estimate mu at a 90% confidence level. Okay, so check a condition. Number one is randomness. We have to assume it. So we're going to assume SRS because they didn't say in the question that they just said a sample. They didn't say a random sample. So we're going to assume there is an SRS. This question just gets worse and worse. Then we need independence. So 40 is less than 10% of all cars. I'm pretty comfortable with that. And then I need a justification for being able to use the t-distribution. And there's three possible things. Which one of those possible things do we have in this example? Samples larger than 30. Sometimes there's more than one and you can kind of pick. But it doesn't tell us the population is normal, so that one's out. It does tell us we have a large enough sample. So n is greater than or equal to 30, which means I have a large enough sample. Alright, so then for your math box, you're always starting off with the general formula. So statistic plus or minus critical value times standard deviation of statistic. Am I going too fast? Are we okay? I'm nervous. I don't realize I'm going too fast. Sanson, am I going too fast? Thanks. Okay. What's the statistic? Like represent it with a letter. X bar. Now we're cooking. Critical value is T star. Why is it T star instead of Z star? Because we're dealing with means. If we were dealing with proportions, it'd be Z's. So standard deviation is the standard deviation of the square root, or the standard deviation divided by the square root of that. So what is X bar in this case? 1. plus or minus. I'll show you T star in a second. What's the standard deviation? 2, and then divided by the square root of 40. So T star. So go to your calculator. And go second distribution, like just like you were going to go to inverse norm. But if you scroll down one more, there's inverse T. And one thing that's kind of nice is if you forget the degrees of freedom, your calculator will give you an error, so you kind of know you screwed up. So if you just do like 1.9 divided by 2, your calculator's like, well, you didn't give me enough arguments. Like I'm expecting a comma and then something else, basically, is what that means. So if you forget it, you do get reminded. And then what you do is put 39 because it's one less than the sample size. You don't need to do this with proportions. You do need to do this with means. Yeah. Hit enter. So I get 1.685. Did everybody get 1.685? We're all getting that. Calculators are working. Okay. Your calculator does this test also. So you can do the math, but I'm just going to show you how to do, like, to not do the math. So go stat, tests. You don't want to do a regular t-test. Wait, I can't ever remember. Maybe you do. Oh yeah, we're on intervals, aren't we? T interval, number 8. So there's 2 ways you can do it. Up here, you're asked to choose between data and stat. So if you had like a list of data in your L1, you could just like, hey, look at L1 and figure everything out. But we don't have that now. We have the stats. We have like the summary information. And so we're going to type that in. So X bar is 1. The standard deviation is 2. And is 40. Confidence level is 0.9. We good? You with me? Okay, calculate. And so you still have to write this part, but that kind of shortcutted us to here. So 0.467, comma 1.53. And so this is 1, right? Like this blank. And then you got to figure out the margin of error still. And so remember, 1's kind of like 1's the middle. So the margin of error is either this minus 1 or 1 minus this. You get the same thing either way. So it's basically plus or minus 0.53. You guys with me what I'm doing there? So let me ask you this. Is it reasonable to assume that the gas mileage increased? Yes. Why? Everything's above 0. If it was like negative 0.5 to 0.5, would it be reasonable to assume the gas mileage increased? No, because 0's in there. Okay. And then we just summarize it. So we are 90% confident that mu is between 0.467 and 1.53. I forgot one thing, though. Hold on. Well, we're almost done. But are there questions on what I did here? But I did forget one thing. I gotta go back and put it. Any questions on what I have here? So remember the degrees of freedom that we put in, the 39? We have to label that. So just anywhere kind of off to the side, I'm just going to go degrees of freedom equals 39. DF equals 39 is totally fine. It's like a measure of how certain we are. So the degrees of freedom, if I have 40 data points, I technically, and I know the mean. If I know 39 of the data points and I know the mean, I can figure out that 40th one. I don't technically need it. So there's only like 39 points required to get to that 40th. It's a weird concept. Yeah. If I tell you, like, here's 39 data points, and the mean is this, could you figure out the 40th data point? Yes. That's what the degrees of freedom is representing. You only need 39 of the 40 data points to get to know the 40. It never comes up. You don't have to know that. Any other questions on this process or where this is, anything I'm doing here? So try number 3. Number 2 is one of those annoying dot plot ones. We'll probably do that together tomorrow. This was written back when students took the ACT. So there were, 370 or more students that have taken the ACT. I guess we're just kind of pretending that part now. Because 37 is not less than 10% of the students here that have taken the ACT, right? So we're kind of BS in that part, but that's okay. It used to be true. After this, you guys are going to do one. So you're going to make up your own question. You're going to ask 30 people, so you have a large enough sample. You're going to do a confidence interval to estimate the population mean of your question. So the difference is this time it can't be a yes/no question. No, it's proportional.
No, actually, it's specific. No,
It's got to be the question has to have a numerical answer. So
that's a number more like.
how many times in the last week have you got to talk about? How many hours of sleep did you get last night? How many siblings do you have? How much money do you have in your pocket? I mean, anything that gives you a number. And then you got your 30 data points. You can find the mean and the standard deviation of those. And then you're going to make a confidence interval from that.
If they don't tell you the truth, it's not an outlier, it's a real liar.
Yeah.
So that's supposed to be 95%.
Oh, yeah, good call. You know what? I'm changing the plan a little bit. We're going to do it as a class. Because I want to have everyone have the same answer. But I need people to go ask other. Either way. What questions should we ask, Mr. Porter?
Don't do the picking your nose one. That's that.
How many hours of sleep did you get last night?
Yeah, that's a good one.
Alright, so we're going to go around the room, and then someone's going to go over there and ask everyone in there, too. I want to show you how to do it with the data thing in your calculator. So I got, Mr. Porter, how many did you get?
7.
I got 6, and then we're going to go around this way. Caden.
9. Whoa!
I would.
7.
Yeah, this isn't counted in school.
6. Stop. Are you counting on your fingers?
Yeah, I feel like 7.
Okay.
Which is more than usual. 7. 6.
Bingo. They say you should get 8.
All right, we're gonna do this one. I don't want the more data points now. I've changed my mind. Change of plans. Because then we're gonna go through one where you don't have enough. Thank you, Mr. Porter. Anyways. Okay. I want you to put those numbers into your L1. Stat, edit. So yeah, remember, don't delete the column because that'll destroy the column. Clear the column. So I think there's 15 numbers. So get those in, and then I'm going to show you how to use the data thing, and then I'm going to have you write the confidence interval essay based on that. Would it help if I read them? Should I read them? Doesn't matter? Okay. I mean, it's easier if it's in front of you. You can like cross them off.
Is there
Right?
16 numbers?
15.
Oh, yeah.
When it says 16, it's like waiting for the
Yeah.
16. Yeah. Kind of just got to be a weirdo. Got 8.37. Yeah, I don't think we're getting enough sleep. Except for Caden.
Sleeping more than
Some of you are probably counting on a couple hours in school to make up the difference. All right, does everybody have the numbers typed in? Or should I wait a little longer? Peyton, you still typing? Okay. Okay, now go to stat test interval again. So go to your T interval. But this is the opposite situation. I don't have like the summary statistics. Like I didn't calculate the mean. I could. I don't really want to. I didn't calculate the standard deviation. I could. I definitely don't want to. So I'm going to go to data, and you just tell the calculator, hey, you go to L1, You figure out all that crap. I don't want to. Leave that frequency as, I'm assuming yours all just say 1. So just leave it there. And let's do a 0.95. And then if you hit calculate, it tells you all the stuff you need. So there's your confidence interval. There's your X bar. There's your standard deviation. And so we could do, like, I don't even need you to write up all the stuff. I just wanted to show you that. Does that make sense? You guys all get what I'm getting there?
What's the confidence level?
I did 0.95. Just make sure you match up with my numbers. So just understand that there's 2 options. If you have a list of numbers, you can make the calculator do all the work for you. And if you just have like the summary of the statistics, you can do it that way too. I'm guessing you guys don't want to write another one. Yeah, I'm fine with that. You guys alright? Okay, I'm good then.
Waiting to hear back the girl I knew when I was back to her here, but she got back to her.
She got evacuated?